Right now, as you watch this, a storm older than modern science is tearing itself apart 600 million kilometers from where you're sitting. A storm that has been raging since before Isaac Newton published his laws of motion. Before the United States existed. Before the telescope even had a name. And within your lifetime, quite possibly within the next 20 years, it will be gone, not weakened, not dormant, gone. And the part of this story that should genuinely stop you cold is this. You are one of the last generations of human beings who will ever be alive to say they existed at the same time as Jupiter's great red spot. That is not hyperbole. That is a scientific fact with a closing deadline. Jupiter's great red spot. Say that name to any planetary scientist and watch something shift behind their eyes. It's not nostalgia, it's urgency. Because the storm that generations of astronomers assumed would always be there, always churning, always available for the next wave of scientists to study, is in active collapse. NASA's Juno spacecraft put its current width at approximately 13,000 kilometers as of its most recent close passes. 13,000 kilometers. That sounds enormous, and it is enormous, still wider than Earth itself. But in 1879, the Great Red Spot was measured at 48,000 kilometers across. We have watched this storm lose 2/3 of its total size in less than 150 years. And crucially, it is not slowing down. If anything, recent data suggests the rate of shrinkage is accelerating. That is not a slow fade into history. That is a collapse in slow motion, happening right now, and you are watching it in real time. But here is the thing that not enough people are saying loudly enough. The Great Red Spot is not just a storm. It is a scientific instrument. It is a living laboratory. It is a window into planetary physics that exists nowhere else in the solar system. And when that window closes, it closes permanently. Not expensively, not inconveniently, permanently. The data we can extract from an active, churning, living Great Red Spot is categorically different from any data we could ever extract from its memory. Future scientists will study our archives. They will be grateful for our records. But they will never be able to run a new experiment on a living storm, because it simply won't exist to run experiments on. To understand what we're losing, you first have to understand what we're dealing with. Jupiter is not a planet your intuition is built to process. It is a world of pure, stacked extremes. Jupiter is so massive, 2.5 times the combined mass of every other planet in the solar system, that it doesn't technically orbit the Sun alone. Jupiter and the Sun orbit a shared gravitational center, the barycenter, that sits just barely outside the Sun's own surface. Jupiter is gravitationally tugging the Sun. Its magnetic field is 20,000 times stronger than Earth's. Its magnetosphere, the bubble of magnetic influence it projects, is so vast that if you could see it with the naked eye from Earth, it would appear 5 times larger than the full moon in our sky. Its core generates so much internal heat that Jupiter radiates nearly twice as much energy into space as it receives from the Sun. And on the churning, banded, utterly alien cloud tops of this monster sits the most powerful, long-lived storm in the known solar system. The Great Red Spot is an anticyclone, a massive, high-pressure system rotating counterclockwise once every 6 Earth days. Its winds at the outer edges exceed 640 kilometers per hour. To put that in perspective, the fastest tropical cyclone wind ever recorded on Earth peaked at 408 kilometers per hour. The Great Red Spot's winds would shred that record, and those winds are so violently energetic that the acoustic waves they generate, the literal sound of 350 years of atmospheric fury, heat the atmosphere above the storm to temperatures higher than anywhere else on Jupiter. Sound is heating a planet. That is not a metaphor. It is confirmed, measured, peer-reviewed physics. Juno's microwave radiometry data has mapped the storm's routes to over 500 kilometers below the cloud tops, plunging deeper into Jupiter's atmosphere than the width of the continental United States. Deeper than any storm on any world we've ever studied in this detail. And this ancient, deep, violent, extraordinary thing is dying. So, what is killing it? The answer is actively contested, which makes the urgency even greater. The leading mechanism appears to be vortex shedding. For decades, the Great Red Spot has been observed ejecting fragments of itself, pieces of its outer ring that get sheared away by the jet streams flowing above and below it and drift off into Jupiter's broader atmosphere. In 2019, real-time observations caught this happening dramatically. Visible chunks of the storm's structure being literally ripped away, streaking into the surrounding cloud bands. And here is the cruel irony. Those jet streams, two massive rivers of atmosphere flowing in opposite directions, one above the spot and one below, are the same currents that kept the storm alive for centuries. They trapped it, they fed it, they anchored it. But new atmospheric models published in 2022 and 2023 suggest that as the spot shrinks and becomes more circular, it's losing its ability to resist those same currents. The anchor is becoming a liability. The spot gets smaller, its interaction with the jet streams weakens, it sheds more mass, it gets smaller still. A feedback loop, a death spiral measured in decades. And here is where the story pivots into something philosophically disturbing. Because the Great Red Spot has very likely died before. The 17th century astronomer Giovanni Cassini, not the spacecraft, the man, observed and meticulously documented what he called a permanent spot on Jupiter, beginning in 1665. He tracked it for nearly 40 years. And then, between 1713 and 1831, the historical record goes silent. 118 years. When a spot reappeared, modern researchers now believe it was almost certainly a successor, a different storm that formed after the original collapsed, unseen, unrecorded, unnoticed. A storm many times the width of Earth fell apart between telescope observations, and nobody knew. Nobody marked the moment. Nobody wrote an epitaph. Because the universe does not send a notification when something extraordinary ends. It just changes. And if we are not watching, closely, carefully, continuously, the change becomes invisible. The loss becomes unknowable. What if we had caught Cassini's spot in its final years? What would those observations have told us about the mechanisms of giant vortex collapse that we still don't fully understand today? What would those insights have changed about our models, our predictions, our science? We don't know. We can't know. The data window closed 118 years before anyone realized it had opened. That is the terrifying quiet of cosmic loss. The universe doesn't care what we could have learned. It just moves. Now think carefully about what we have already learned from this storm. Knowledge that required the Great Red Spot to be active, to be alive, to be observable with instruments sophisticated enough to read it. The spot has allowed planetary scientists, using infrared spectroscopy, to resolve Jupiter's cloud structure into 3 distinct layers: ammonia ice at the upper deck, ammonium hydrosulfide below, water ice deeper still, layers that are impossible to observe anywhere else on Jupiter with the same precision, because the atmospheric thinning at the storm's eye creates a unique window into the planet's interior. Our entire working model of gas giant atmospheric architecture is built substantially on data extracted through that window. And that model directly informs how we think about the atmospheres of the 5,500 confirmed exoplanets we've identified around distant stars. Worlds we will never visit. worlds we can only understand through analogy and spectroscopy. The Great Red Spot has been our Rosetta Stone for gas giant atmospheres across the galaxy, and the Rosetta Stone is dissolving. Beyond atmospheric science, studying how the Great Red Spot sustains itself against surrounding turbulence has given scientists foundational tools for understanding atmospheric blocking events here on Earth. Atmospheric blocking is when a large, high-pressure system parks itself over a region and refuses to move. It caused the European heat wave of 2003, which killed 70,000 people. The Russian drought of 2010 that incinerated 40% of the country's wheat crop. The simultaneous multi-continental crop failures that food security analysts now identify as among the highest risk vectors for global destabilization. Our capacity to predict those events weeks in advance, to issue heat warnings, to adjust harvest expectations, to flag food supply risks before they become crises, traces a direct scientific lineage back to what we learned from studying a storm on a world 600 million kilometers away. That is not poetic. That is a supply chain of knowledge. And part of that supply chain depends on a laboratory that is about to permanently close. Juno's most recent flybys, including gravity science measurements from 2023 and 2024, detected subtle fluctuations in mass distribution beneath the Great Red Spot, hints at subsurface dynamics that are not yet understood. There are scientists, right now, writing papers with an urgency that is alien to the normally unhurried pace of astronomical research. In most of astronomy, you don't feel rushed. The Andromeda Galaxy will be there next decade. The pillars of creation aren't going anywhere. You have time. But the scientists studying the Great Red Spot are experiencing something their field almost never demands of them. A cosmic deadline. Not a grant cycle, not a publication window. A deadline set by the storm itself, counting down in years we cannot precisely calculate and cannot extend. And this is where the story expands into something that should genuinely reframe how you see the universe. What is happening to the Great Red Spot is a microcosm, a small, local, comprehensible version of something happening at every scale of the cosmos simultaneously. The universe is not a permanent stage. It is a machine winding down, spreading out, and erasing its own history as it expands. The cosmic microwave background radiation, the single most important piece of evidence for the Big Bang, the faint thermal echo of the universe's first 380,000 years, is red-shifting. Its wavelengths are being stretched by cosmic expansion. It is growing fainter. In a few trillion years, it will fall below the detection threshold of any instrument any civilization could build. Any species that emerges after that moment will look out at a universe with no traceable origin. They will be brilliant. They will be curious. They will build instruments and ask hard questions, but they will be missing something so fundamental to understanding reality that we cannot fully calculate what errors will compound from that absence. They will not know what they don't know. That is the deepest kind of ignorance. And it is the kind that no intelligence, no matter how advanced, can self-correct from without evidence. We are not at risk of that particular loss, but we are living in a smaller version of the same story. The Great Red Spot is the cosmic microwave background of our solar system. It is a living record, a window into history. And when it closes, entire categories of planetary science will begin calcifying around whatever we manage to record before the deadline. The difference between us and that future civilization is this. We still have time. Not infinite time, not comfortable time, but time. And we are awake to it, which is everything. Here's the part that should make this feel personal, because it is personal. Jupiter's Great Red Spot is visible with a modest backyard telescope. On a clear night when Jupiter is near opposition, closest to Earth, brightest in the sky, A 4-inch telescope can resolve the storm. Not a suggestion of it. The storm. And amateur observers have contributed meaningfully to the professional observational record. Organizations like the Association of Lunar and Planetary Observers cross-reference amateur data with professional data sets. Your observation, yours, made tonight, from your backyard or a local observatory or a borrowed telescope, can become part of the permanent scientific record of something that is going to be gone within your lifetime. You have the specific, unrepeatable opportunity to witness and document something that no one born after you will ever be able to observe for themselves. Not with better equipment, not from a closer vantage point, not under any circumstances, because it simply will not be there. Every civilization that has ever pointed at the sky and decided something was permanent has eventually been wrong. The stars are not eternal. They burn out. The galaxies are drifting apart, carried by the expansion of space itself. The universe is not a room. It's a room whose walls are accelerating away from the furniture. But right now, in this brief window of cosmic time, the sky is readable. The record is legible. The evidence of everything, from the Big Bang to 350 years of atmospheric fury on a gas giant, is still alive and visible and detectable. And we, this generation, this narrow sliver of curious, tool-building, sky-watching biological intelligence, we are positioned to read it. We didn't earn that. We happened into it by the extraordinary accident of being born now. But we can choose what we do with that accident. The Great Red Spot will die. The current best estimates put it between 10 and 30 years away from dissolution. Some models say less. None say it is recovering. When the last of its structure is finally sheared apart by the jet streams that sustained it for centuries, there will be no explosion, no signal, no moment of cosmic drama. Jupiter will simply look slightly different one day, a smaller oval, a fading reddish smear. And then the banded cloud tops will close over it and roll on, indifferent, as they always have. The universe doesn't mourn, it just moves. But we can mourn, and we can observe, and we can record, and we can understand, because that is what we are. We are the part of the universe that noticed. We are the part that looked at a storm on a gas giant 600 million kilometers away and said, "That is strange and beautiful and worth understanding," and then built instruments and launched them across the void and read what they sent back and wove it into knowledge that helped us feed more people, predict more disasters, and imagine the weathers of worlds around distant stars. We did that. The storm didn't do it. We did. And every bit of that, the curiosity, the instruments, the knowledge, the archived data, can outlast the storm by billions of years if we choose to carry it forward. You are alive to watch the solar system's greatest storm die. Let that be the most extraordinary sentence you read this year. Not because it's sad, though it is, but because of what it implies. It implies that you are here, now, in this precise and unrepeatable moment in the history of the universe, when the sky is still full, and the evidence is still readable, and the storm is still alive. Go find Jupiter in the sky tonight. Point something at it. Look at a reddish oval on a striped giant and understand that you are watching a 350-year-old atmospheric titan in its final chapter. And then tell someone, because the universe doesn't stay this legible forever. And not enough people know that the deadline has already started. Drop a comment below. Tell me, did you already know the Great Red Spot was dying? Because I genuinely think most people don't. Share this with someone who should. And if this is the kind of science, the kind that makes you feel impossibly small and impossibly lucky all at once, then you already know what to do. The storm is still out there. For now.